Dear students, today in this class we'll be learning how to find the convolution sum between two finite sequences and two infinite duration sequences and one infinite and one finite duration sequences. In the previous class, we have discussed how to find the convolution sum between two step functions, in which both the step functions are starting at n equal to 0. So in this example, we'll take x of n equal to u of n, where u of n is 1 from 0 to infinity, and we will be taking an impulse response h of n as u of n minus 3, in which the step input is shifted by 3 units towards right. That means u of n minus 3 is 1 for n greater than or equal to 3. So as we have assumed x of n and h of n as both two infinite sequences, the convolution sum has two cases. The first case will be n less than 3, or I can say n minus 3. How do we get n minus 3? H of n is n minus 3, u of n minus 3. So this time index, it should be less than 0. That is the starting of u of n. And the second case is u of n minus 3. The index is n minus 3, which is greater than or equal to 0. Again the starting index of x of n. So we'll be having two cases. One is n less than 3 and the second one is n greater than 3, for which we need to find the convolution sum. We know that the convolution sum is represented by this equation, in which first you need to simplify x of n as u of n and h of n as u of n minus 3. Same way x of k will become u of k and h of n minus k will become u of n minus 3 minus k. So now we need to find the convolution sum using graphical method. So first you need to sketch u of k. So u of k will look like this, and now I need to sketch u of n minus 3 minus k. How do we sketch u of n minus 3 minus k? First we need to sketch u of k minus 3. Then you need to fold u of k minus 3. So that will look like this. Then we need to multiply u of k and u of n minus k minus 3. So if you observe carefully, in this case, the samples of both the signals are not overlapping. That means to say I cannot multiply any of the samples of u of k with u of n minus k minus 3. So therefore y of n is equal to 0 for the first case, that is n less than 3. Next we'll see for the second case, n minus 3 greater than or equal to 0, or I can say n greater than or equal to 3. So again in this case, since n minus 3 is greater than or equal to 0, we need to move h of n minus k towards right, and that shift, it should be greater than or equal to 0. Then you need to multiply x of k and h of n minus k. So when you see the product now, the samples of x of k and h of n minus k, we can multiply the samples between the range 0 to n minus 3. So now the equation, the convolution sum equation summation, it will change to 0 to n minus 3, and since it is u of k and u of n minus 3 minus k, we are multiplying, that product will become 1. So when we simplify this, y of n will take the value n minus 2. So therefore the convolution sum between u of n and u of n minus 3 is equal to 0 for n less than 3 and it is n minus 2 for n greater than or equal to 3. Okay, now let us take the second example where I am assuming the first sequence as an exponential sequence where beta is again it is less than 1 and the second sequence h of n I am taking an unit step function which is shifted by 3 units towards right. Now you replace x of k by beta to the power k u of k and h of n minus k by u of n minus 3 minus k. Now, as in the previous case, you first sketch u of k, u of n minus 3 minus k. Then for the first case, n less than 3, you need to move u of n minus 3 minus k towards left. That is n minus 3 less than 0. So in that case, none of the samples of both the signals are not overlapping. So therefore, the convolution sum y of n is 0 for the first case. Coming to the second case, that is n minus 3 greater than or equal to 0. In that case, you need to move u of n minus k minus 3 towards right by n minus 3. That is, it should be that n minus 3, it should be greater than or equal to 0. So it should lie between 0 to infinity anywhere. When you multiply u of k with u of n minus k minus 3, you can see we can multiply the samples of both the signals in the range 0 to n minus 3. So now the summation range will change to 0 to n minus 3 beta to the power k and this u of k and u of n minus k minus 3 it is 1. So in the previous class we know that the summation series k equal to 0 to n a power k is given by 1 minus a to the power n plus 1 divided by 1 minus a. In this problem, a is replaced by beta and n is replaced by n minus 3. So when you simplify, you will get y of n is equal to 1 minus beta to the power n minus 2 divided by 1 minus beta. So we can say the convolution sum between an exponential and u of n minus 3 is 0 for n less than 3 and it is 1 minus beta to the power n minus 2 divided by 1 minus beta for n greater than or equal to 3. Now let us consider two finite sequences in which given x of n is u of n minus u of n minus 3 and h of n as u of n plus 1 minus u of n minus 3. This problem can be solved in two ways. One is first you find out the samples of x of n and h of n and then compute the convolution sum using graphical method. So by sketching u of n minus u of n minus 3, we can get x of n as 1, 1, 1 and the length of the sequence is 3. Similarly, if we find h of n which is equal to u of n plus 1 means it is starting from minus 1 to infinity and u of n minus 3 means it is the signal is starting from 3 to infinity. So when you subtract these two signals, you will get only the 4 samples from minus 1 to 2. So that is h of n is 1, 1, 1, 1. So you got two finite sequences x of n and h of n. Now, since we know how to compute the convolution sum for two finite sequences using all the three methods, you can solve using any of the methods and you will get the convolution sum for this problem as 1, 2, 3, 3, 2, 1 in which the arrow mark indicates the origin. That is, it is at 0. The sample is at 0. So you can graphically represent the convolution sum like this. Okay, now let us consider two sequences in which x of n is an infinite sequence and h of n is a finite sequence. We have already learned that whenever we have two infinite sequences, we will be having two cases. Similarly, in case of one finite and one infinite, we will be having three different cases. How do we find those three different cases? Let us first draw x of n and h of n. So now you can see h of n is u of n minus u of n minus 3. So you will get three samples starting from 0 to 2. Now the first case always first case will be n less than 0, that is n less than the starting index of x of n, and the second case is n between 0 and 2, that is the range of h of n, and the last case is n greater than or equal to 2, that is the end index of h of n. So these are the three different cases. We need to compute the convolution sum for one finite and one infinite sequence for the given problem. So simplify x of n as u of n and h of n as u of n minus u of n minus 3. First you draw x of k, that is u of k. Then you draw h of n minus k. H of n minus k is nothing but h of minus k at n equal to 0. Now, what is the first case? N less than 0. N less than 0 means we need to shift h of n minus k towards left and then multiply with x of k and h of n minus k. So, when you multiply these two signals, you can see none of the samples of these two signals are overlapping. So, therefore, y of n equal to 0 for n less than 0. Coming to the second case, that is n between 0 and 2. So, in this case, you need to shift h of n minus k towards right, and that n value, it should be between 0 and 2. And then you need to multiply x of k and h of n minus k. So now you see, in this case, in this product x of k and h of n minus k, only the samples between the range 0 to n will overlap. So the product will be 1 between 0 to n, which can be simplified as n plus 1. Coming to the last case, that is n greater than or equal to 2. In this case, I need to shift h of n minus k towards right. It should be greater than or equal to 2. So then you multiply x of k and h of n minus k. Now you can see the samples x of k and h of n minus k will overlap only in the region 0 to 2. 0 to 2. So in the convolution sum expression, you change the summation range as 0 to 2 and the product is 1. So you are adding 1 for 3 times. So y of n is 3. So therefore y of n is 0 for n less than 0, n plus 1 between 0 to 2 and 3 for n greater than or equal to 2. So when you simplify different values of n, you will get the convolution sum graph like this. I think we have discussed all the different cases of signals, two infinite signals, two finite signals, and one infinite and one finite duration signal. So we can conclude that the number of cases which exist for convolution sum for two infinite cases is infinite sequences, two cases, one infinite and one finite is three cases, and two finite cases is five cases that I will be discussing in our regular classes. Or you can also solve using the general method where you can compute the number of samples and the amplitudes by sketching x of n and h of n, and then you can solve it using graphical method. And these are the problems for today's assignment. So x of n is equal to u of n and h of n equal to u of n minus 5. This is same as example 4. And the second one is x of n is half to the power n u of n, h of n equal to u of n minus 2. It is same as example 5. And this, the last problem, is similar to example 6. So in the next class, we'll discuss the properties of convolution sum. Thank you.